Good morning, students. Today we are going to discuss about QUine MC Clusky method, otherwise said to be tabular minimization method. So this method was first developed by QUine. Later, it was further developed by Clusky. Hence, it is also called as QUine MC Clusky method, tabular minimization method, otherwise said to be QUine MC Clusky method. So now, why we are going for tabular minimization? Why not K-map? So till now we have seen the implementation of logic circuit by using K-map. So how to minimize those logical function or the given Boolean function, and then how to implement that with the help of simple or minimal number of gates. That is what we have discussed so far. So the reason for going into K-map is, so K-map will be convenient only up to 6 variables. 5 to 6 variables. Convenient only up to 5 to 6 variables. For more than 6 variables, there is no guarantee that the best selection can be done. Meaning, so you are going to combine either a number of ones in case of min terms or number of zeros in terms of max terms in a K-map. So why you are going for the combination of number of ones or zeros? To minimize the number of literals. To minimize the number of literals. So if you are minimizing the number of literals, the number of gates will also be reduced. That is why you are going for K-map minimization. But for variables more than 6, we cannot assure that the combinations that we are making with ones or zeros in the K-map can be the best. Okay, can be the best. So for that case, we are going ahead with tabular minimization, and it consists of two parts. Namely, it is the first thing is among the given function, in the given function, search what are all the terms that is being present, and among those terms which can be included in the final simplified function, or which can be included in the simplified function. That is step number 1. Okay, that is the first step. That is the terms, the selection of those terms, that is said to be prime implicants. That is said to be prime implicants. Then the next step is among the prime implicants, what should appear at the final function, final simplified function. So choose among the prime implicants that give minimum number of literals. That is the from the prime implicants, whichever prime implicants is giving the minimum number of literals, that can be chosen and it can be given as the output function. This is your K-map. This is your tabular minimization. So take this function x is equal to the given function. Reduce the given expression by tabular minimization. So now, what is this? Let me write what is the min term. Okay, so this is 0, 0, 0 and 1, and this is 0, 0, 1 and 1, and this is 0, 0, this is 1, 1, 0 and 0. This is 1, 1, 0 and 0. 1, 1, 0 and 0, whereas this is 0, 1, 0, 1, and come back to this. This is 1, 0, 1, 0, and this one is 1, 1, 0, 0, 1, 1, 0, 0. So this one is 0, 1, 0, 0. Okay, 0, 1, 0, 0. This one is 0, 1, 0, 0. Whereas the other two terms are 1, 1, 0, 1 and 1, 1, 1, 1. So what is this? So x is equal to, in terms of min terms, how will I write? First one is m1 plus m3, and what is 1, 1, 0, 0? 1, 1, 0, 0. 1, 1, 0, 0 is 12. Okay, so m12 and m5 and 1, 0 is 0 is m10, I hope. M4 and 1, 1, 0, 1 is 13. 1, 0, 1, 0, 1, 0 is 1. 1, 10, and then 30. So then M13 and M15. These are all the minterms for which your output is 1. Okay. So let us go ahead with QUine MC-Clusky method. So these are all the minterms that is being present. So let me write it in ascending order. M1, M3, M4, M5 and M10, M12, M13 plus M15. Okay, M15. So now first what we need to do is we need to put a table in such a way that we are having what are all the minterms we have? We have 1 3 4 5 1 3 4 5 10 12 13 15 10 12 13 15 10 12 13 and 15. Okay, so right in the table, first column is combine the minterms. Okay, the first thing is minterms with number of ones, okay. So now what is this 1 is said to be 0 0 0 1 and this is 0 0 1 1 0 1 0 1. So 0 0, sorry, so 0 1 0 1, okay, 1 0 1 0 1 1 0 0 1 1 0 1 1 1 double 0 1 1 0 1 1 1 1 1. Okay, now so see this 1, the minterm 1 and the minterm 4 has only 1 once. Okay, has only 1 1. So combine the minterm such that with the number of ones, So how we are going to combine? Okay, that is what in the table you need to write. So what is the first step? Combine the minterms. What are all the minterms you can combine? You can combine 1 and 4, because 1 and 4, what does it has? It is 0 0 0 1 and 0 1 double 0. So this is with the minimum 1 number of ones. Okay, with this is with minimum 1 number of ones, where this is A, B, C and D. Okay, so this is the first combination. What about the second combination? So let me combine with 2 number of ones. So 2 number of ones will cover 3, 5 and 10 even 12. So 3 is 0 0 1 1 0 1 0 1 1 0 1 0 1 1 0 0. Okay, so with the 2 number of ones I have clubbed. Similarly, what is the rest? What are all the rest is there? See, 2 ones, 2 ones, and 2 ones. What is the rest we have? We have 3 ones and 4 ones. 3 ones and 4 ones. Again, make the combination like this here. Okay, so that is what I have written here. See here, club the minterm based on the number of ones. Okay. So what is the first one I have written previously? 1 and 4. Okay, 1 and 4. 1 and 4. So 1 is 0 0 0 1 and 4 is 0 1 double 0. And what about the next one? We have 2 ones. What are all the minterms having 2 ones? 3, 5, 10 and 12. So 3, 5, 10 and 12. So with 2 ones. And what is left? With the 3 ones you have 13 and 4 ones you have 15. So with 3 ones I have the minterm M13. With 4 ones I am having the minterm F15. This is just step 1. Okay, this is step 1. and this is the truth table as I have given for the following function. Okay, following function for what, for these minterms your output will be 1. That is what I have given here. For these minterms your output will be 1, whereas your input variables are a, b, c, d for the given function. Okay, for the given function. And what about the next one? Combine the first combination has been done. Am I right? First combination have been done. So now for the second combination, let me come back again. So in step 2, okay, in step 2, what we can do is, okay, so combine the two minterms that is available in the immediate row, the next immediate row. So meaning the first row can be clubbed with the second row, and the second row can be clubbed with the third row. Third row can clubbed with the fourth row. Only this sort of minimization is possible. Like 1 cannot be clubbed with the 3. Okay, that is not possible. A direct jump is not possible. So step 2 is nothing but, okay, combine the minterms in the adjacent row such that the two minterms that we are combining should vary by only one variable. Only one variable. How we can do this combination? Let us take this 1. Okay, so let me take this 1. Okay, let me take this 1 and check with the next rows. What is the next cell? This is 2. So let me combine here. So M1 can be clubbed with the M3 because see, the first 0, second is 0, and the last term is 1 and 1, whereas the third from the leftmost third bit it is 0, this is 1. This is varying by only 1 bit position. So how to write this? So M1 can be clubbed with M3, and this combination in the second level, okay, this combination in the second level can be written as 0, 0. Only the third bit position is varying as 0 and 1. So x, and fourth bit position is 1. So 0, 0, x and 1. So that is what I have written. See, M1 is clubbed with M3. Okay, M1 is clubbed with M3, and I can write like this. Okay, and then again check for M1. M1 can be checked with M5. So the first nibble from the left side is same. So the second nibble is changing. Third and fourth is not changing. So M1 can be clubbed with M5. So if it is clubbed with M5, I can write it as 0, x, M1 can be clubbed with M5. So 0 and 1. So that is what here I have written. See, 0, x, 0 and 1. Check for the 4. 0, 1, 0, 0. So we need 3 zeros and 1 ones. And in the same bit position it should change. So in the second adjacent column, what all you have? You have other than 3 cannot be clubbed because 2 bit positions are changing. M4 cannot be clubbed with the M3. And then M4 can be clubbed with M5. Yeah. See here, M4 can be clubbed with M5. Okay. So if you look ahead, so this is 0, 0, 1, 1, 0, 0. This is 0 and 1. So if I am combining M4 with M5, how can we write? 0, 1, 0, x. x is the term. Why we are writing x? It can be 0 or 1. So in m1, for example, one of the term, what is m1? 0, 0, 0, 1. What is m5? 0, 1, 0, 1. Okay, the second term is varying. That is why this second term I am writing it as x. Okay, again m4 can be clubbed with m12. M4 can be clubbed with m12. Let me check. See, m4 is, this is 0, this is 1. So in the most significant bit I have to have place x. So at the later the other 3 bits are same. See, this is 100. This is also 100. So x 100. Okay. So now m4 and m1, this m4 and m1 of the first row, okay, the first row has been compared with the m3, 5, 10 and 12, and we have written this. Okay, and we have written this up to this. Namely, this is for the first row. This is for the first row. This is for the first row. So first is nothing but compare row 1's minterm with row 2 minterms. This is the first step. Okay. The next step is now compare your second minterm. Now compare your second minterms. What are all in the second row? M3, 5, 10, 12. Take each minterm, compare with the adjacent terms, adjacent row terms. Take M3. What is there in M3? 0, 0, 1, 1. What is there in M13? 1, 1, 0, 1. See, now two variables are changing. So M3, see, this is 0, 0 and this is 1, 1. Here itself there is two variable change. Again 0, 0, 1. Here we have in M3, whereas in M13 it is 1, 1, 0. So all the three minterms, first three bit positions are changing. So we cannot club M3 with M13. So go ahead with M5. M5 and M13, instead of the 0 I have 1 here. Okay, the second bit term 1 and 1, so like term, 0 and 0 like term, 1 and 1 like term. Okay, so here M5, this 101 and M13 101 are same. So only the most significant nibble is changing. So I can write X101. So see here X101 for M5 and M15. Next take M10. So M10 should be compared with M13. So this is okay, this is right, but this is changing. This is changing. So I can, because these two bits are changing. This is 0, 1. This is 1, 0. 0, 1, 0. This is 1, 0, 1. Okay, I cannot club this M10 with M13. Okay, two bit changes not allowed at the first level. Okay, and then go ahead with the M12 and M13. Either it is possible. Okay, so what is your M12? M12 is 1100. M13 is 1101. So only one bit changes here. So this one and this one is changing. So I can write it as 110x. So M12 and M13 I can write it as 110x. Okay. So now for all the minterms of row 2 has been clubbed with the adjacent term, which is nothing but adjacent row, which is nothing but M13. Next, what we have to do, I need to compare the minterms available in row 3 with row 4. So I need to compare M13 and M15. Look ahead with this. So this is 1 and this is 1 and whereas this is also 1. So only this position is changing, 1, 1, x 1. So 1, 1, x 1. So in the first level, this is being combined. Okay. So this is these two are second compared with third, and this one is third compared with fourth. Third compared with fourth. So see, from number of rows 1, 2, 3, 4, we have minimized to 1, 2, and 3. Okay, we have minimized to number of 3. The extra level we can go step 3. Okay, step 2 I have written here. I have written here again, and step 3 I can go ahead now. Again in the same way. Again in the same way. As I said, now the number of rows has been minimized to 1, 2, 3. Okay, and we know what are all the combinations: M1, M3, M1, 5. Okay, M1, M3, M1, M5, M4, M5. That is here M4, M12. That is your first level. I said no. This is first, and this is 2, and this is 3. In the second I will be using 2, and the third I will be using 1, and its corresponding ABCD literal management is given here: 00x1, 0x01, and 010x, x100, x101, 110x, 11x1. Okay. So now earlier we have seen 1-bit position change. Now we need to see 2-bit position change. Okay, 2-bit position change. So let me take M1 and M5. Okay, 2-bit position change. So 2-bit position change, how will you write? Again, from here you just take M1, M3, club with M5, M13 and check. M1, M3 is 00x1. This is x101. Only 2-bit change is allowed. Meaning, here also in the next step, only other than your x, only 1-bit change is allowed. See, in this combination here, see, look at each stage, look at the minterms. What are all the minterms? From here, it has been transferred to here. So 1 is transferred, 4 is transferred, 3 is also transferred, 5 is transferred, 12, 13, 15 is transferred. Which is not transferred. Okay. You write this M10 and keep it as such, because this has to appear in the final expression. Okay. So M10 is not clubbed with any of the minterms, since this should be included in the final expression. Okay. So now 1-bit change. Now combine what I said, M1, M3 with M5, M13. Only 1-bit change can be allowed, but here it is not the case. So I cannot club this one, because see, already there is an x 0, 1, x 0, 1, 1. So if you chase, more than 1-bit change is there. So I cannot club 1 with 1, 3, 5, 13 is not possible. 1, 3, 5, 13 is not possible. So combine 1, 5 with 5, 13. So 0x, now this is also changing, x 1, that is also changing. So now 1, 5, 1, 5, 13. 1, 5, 13 combination is also not possible. Then M4, M5. Again M4, this is 0, this is x 1, 1, 0, 0, x1. Again 2-bit change. So M4, M5 is not possible with the combination of M5, with the combination of M5 and 13. Okay. And then go for M4, M12. X100, X101. See, here there is only 1-bit combination. This is same. This is same. This is same. And only there is 1-bit change. So here I can write X10X. That is what I have written. See, M4, M5, 12, 13. M4, M5, 12, 13. X10X. What is this X10X? Finally, what you need to write, this is nothing but B, C bar. Okay. So now this is being combined. So we have clubbed. What all the terms we have clubbed? We have clubbed M1, M3, M1, M3 with the two terms, that is not possible. M1, M5 with the two terms, that is not possible. M4, M5 with the M3, M3, 13 is not possible. Whereas M4, M5 with the M12, 13 is possible. That I have written here. And M4, M12, M4, M5 with 12, 13 is possible. Where M4, M5, 13 is also not possible. Okay. And M4, M12 and M12, M13. See, this is changing. This is changing. This is changing. This is same. This is changing. This is changing. That combination is also possible, not possible. So we have clubbed all the four rows of mean terms, one with the next subsequent row terms. Combine and you can check. Okay. So I can tell you clearly here. See, first club. Now these four, these two, this is one. That is what I have written. No? From here, take this 0x0 0x1. Combine with this first term. This is x101. Again, let me combine 00x1 00x1 with what? 110x, which is nothing but this combination, 110x. Okay. So see here there is change, here there is a change, more than 1 bit change. So this is not possible. This combination is not possible. Then go ahead with M1. This is M1, M3. So next take M1, M5. What is that M1, M5? 0x01. Which should be compared with this one, the same combination, x101 and 0x01 with 110x. If you go ahead, see here, more than 1 bit change. So this is also not possible. This combination is also not possible. Okay. Come ahead with this. Now this 0, 1, 0, x. This is first level. 0, that is nothing but M4, 5. 0, 1, 0, x should be compared with the same number, x1, 0, 1. And 0, 1, 0, x has to be compared with 1, 1, 0, x. So this is changing. This is same, this is same, this is changing. This is changing. This is same, this is same, this is changing. So this is also not possible. This combination is also not possible. Okay. So next one, M4, M5, and next is M4, M12. Okay. So M4, M12. What is M4, M12? X100. Now this has to be compared with the x101, because it has to be one has to be compared. Each and every term of 1 has to be compared with the two terms. Okay. So x100 will be compared with x101, and then x100 has to be clubbed with 110x. If you look ahead, this is same, this is same, this is same, only this is different. This is same, this is same. Whereas these two are different. So this combination is not possible, whereas these two is possible. What is these two combination? 010x is 010x is M4, M5. Sorry, this one x100 is M4, M12. Whereas x101 M5 M13. So which combination is possible? M4, M5, M12, M13. So this can be possible for further minimization. So further minimization, how will you write this combination? How will you write this combination? This can be written as x10x. This can be written as x10x, which is nothing but M4, M5, M12, M13. Is that fine? That is what here I have written. Okay, here I have written x10x, M4, M5, 12 and 13. And see, now we have clubbed all the terms of 1 with the terms of 2. Now take 2 and compare with 3. Take 2 and compare with 3. So what is 2? 2 is, we have two terms, x101. So 2 is x101, and what is one more term? Into 110x. So 110x, that is available. These two are two terms. What is there in 3? 3 is 11x1. So this has to be compared with 11x1, 11x1. So here see, both the bits are changing. So this has to be ruled. This has to be ruled. This is changing. This is changing. This also has to be ruled. So what all the term that is here? So this is the only term that goes for the third level. Second or third level? This is first level, the second level. Second level. So now, what are all the miss out terms that we have to see? So this can be written as remove, ignore, don't bother about this x. What is this term? This is A, B, C, D. This is C bar. So the resultant is B, C bar for this second level minimization result. So and again, what are all the other terms that is left? Those things you need to club and write. See, B bar, C bar is there. B bar, C bar, M45 with M45 with 12, 13. That is your B bar, C bar. Okay, that is what I have written here. B bar, C bar. Whereas, what are all the other missed out terms that has not moved to the second level? Okay. Let me write this one from this one. This we haven't combined. So this is A bar, B bar, D. X we need to ignore. A bar, B bar, D. And then A bar, C bar, D. A bar, C bar, D. And this is combined, so we need to ignore. This is A, B, A, C bar. Because this won't be included. See, in the final term, we have this M4 also, M12 also. So this no need to write because that is involved in the final expression. This min term is involved in the final expression. And M5, M13, this also we can ignore because M4, M12, M5, M13, right? M4, M5, M12, M13 is available in the final expression. So again, this combination is also available in the final expression. Ignore this. So 1, 2, 3 ignore. So 3 ignore. 1, 2, 3, 4 ignore because this 4 rows is having M4, M5, 12, 13 combination. So other than that, we need to write 1, 2, 1, 2, 1, 2, 3. 3 is A, B, D. 3 is A, B, D. So this is 3. This is 1. This is 2. Rest all ignore. So this is 1, 2, 3. and then finally we need to include M10. What is that? A, B bar, C, D bar. So the final simplified expression, okay, in the second level, it is this: BC bar, AB, A bar D, AC bar D, AB bar D plus AB bar CD. So these are the prime implicants. These are said to be the prime implicants, without which we won't having the final simplified expression. So these are the prime implicants with minimal number of letters. 1, 2, 3, 4, 5 prime implicants are there. Now write the prime implicants here. So BC bar, A bar, B bar D, AC bar D, ABD, ABC bar. These are the 5 things. And what are all the min terms we have? 1, M1, 3, 4, 5, 10, 12, 13, 15 is the min terms that we have. 1, 3, okay. You can write it from the expression itself, you can write it. What it is there? 1, 3, 4, 5, 10, 12, 13, 15. That is what here we have written. 1, 3, 4, 5, 10, 12, 13, 15. Okay, right. So while you are combining BC bar, while you are getting BC bar, what are all the min terms you have clubbed? BC bar min terms you have clubbed is 4, 5, 12, 13. 4, 5, 12, 13. And A, B bar D, A, B bar D, A bar, B bar D, it is nothing but 1 and 3. And the next one is 1 and 5. 1 and 3. 1 and 5. Then here 13, 15. 13, 15. And A, B bar, C, D, M10. Okay. The first min term, the first two min terms, namely M3 and M5. We need to reduce still further. M3 and M5, the first two min terms, M3 of A, B, C, D bar, which is nothing but M1 and M3. The first two min terms, M1 and M3, okay, M1 and M3, sorry, M1 and M5. M1 and M5, the first two min terms, M1 and M5 available in A bar, C bar, D expression is already covered in the first two rows. See here, let me come here. M45 is covered. Okay, 12, 13 is covered. 1, 2 is covered. Let me, when there is a check box, this is covered for M4. This is covered for M5. And this is covered for M12. And this is covered for M13. And this is covered for this one. This is covered for the rest. This is covered for this. So now, look ahead with these terms. When I see this, here you have already there. And here you have already there. In A, C bar, D bar, what is A, C bar, D bar? 1 and 5. So this row, already this M1 and M5 is covered. Okay, covered. So this can be ignored, meaning A, C bar can be ignored. So in the final expression, you have ignoring this 1, 2, 3, 4 terms. 1, 2, 3, 4 terms. Okay. So that's all about QUine MC Clusky method. This is the final minimized expression. Okay, you can try out for this expression. Reduce the given expression using tabular minimization method. Is it clear? Thank you.